Yeah, you know, it's not being. Watch. 1, 2, 3. Can you hear in the back? I would prefer to have to sit in the, to sit in the front. Oh, I see. Oh, there's no problem. There's no way. There's
Okay, apologies for the delay. There were some technical issues. Fortunately, they got resolved. So it's a pleasure to have with us Professor Leszek Roszkowski. Although it sounds complicated, we know each other for many years, and somehow you manage at the end to pronounce his surname. He's a member of the Polish Academy of Science. He's also a member of the European Science and Arts Academy. He's director of the center called Astrocent in Warsaw, where he returned after being professor at the UK in Lancaster and Sheffield, right? For many years. He came back to Poland to take this position as a large institute with many resources. Actually, those of you who have been to Warsaw will probably know. And it's a pleasure to have him here. He's going to talk about Copernicus. Obviously, that's a world-known figure, actually changed our field, cosmology.
Is the microphone on?
The field of physics.
Microphone?
Sorry?
Oh.
Yeah. Can you hear me? Yes. That's what I thought.
I couldn't.
So I think it's a great opportunity because this is the, I understand, 550th anniversary, right, of the birth of Copernicus. And I think it's a great example of what can change in our worldview. It's difficult to find another similar revolution in science, perhaps that of Darwin, with our understanding where do we come from. But I think nobody better than Leszek to give us some insight into the evolution of these ideas and how did that affect the rest of our understanding of science. Clearly, Copernicus was there to initiate what we understand as modern science. So the title is not just Copernicus half a millennium of modern science, but also a discovery that was not supposed to happen and not become known. And that's the subtitle which got me intrigued. And certainly Leszek will be able to explain to us what did he mean.
Okay.
Thank you.
Okay, thank you very much, Juan, also for the invitation in the first place. Yes, so everybody has heard about Copernicus one way or another and about his great work. Less people perhaps can associate his work with modern science because, you know, what happened half a millennium ago, it's not clear what has to do with modern science. Modern science is what we do here at this conference, Cosmo, and also in the department, in the faculty. That's what the sort of more senior people are doing, and the younger people are starting to learn and do. So, what does Copernicus have to do with modern science? I'll try to convince you that actually his work laid the foundations of modern science in some sense. Now, Juan has already reminded us that we are celebrating this year 550th anniversary of his birth. And in February of this year, there was a World Copernican Congress held in Torun, his birthplace. And I was supposed to go to it. And at some point, I realized that, well, I've heard about Copernicus. I know, you know, especially being from Poland, about him. But how much do I actually know about him? And so I realized that I do not know much actually at all. So I looked into some literature, some books, and I got dragged into an absolutely fascinating story. A fascinating story that I'll try to share with you, at least at some level. And although I'm not sure if I'm the best person to do it, I need to right away say that I'm not a historian. I'm not a historian of science at all. So I'm just an enthusiast in some sense of this case. And in particular, you might be intrigued by the subtitle, like Juan. Why a discovery that was not supposed to happen, nor become known? I'll try to show to you how this happened through a twist of events, basically, unlikely twist of events. And then even that was not sufficient for the discovery to become known, so that we needed more of that. So, and then I'll get appreciated. Anyway, so without further ado, let's just get started. If I see how to change slides now. I'll just click on this. Okay, I'll do that. Okay, so to set the stage, we know that there was one model of the universe, the Ptolemaic model, where the Earth was at the center, and the Sun, the Moon, and the known planets were orbiting it. And then Copernicus, and that model was proposed by Ptolemy in the 2nd century. He lived in Alexandria, although he was Greek, and that model was accepted by the whole world. And then there came Copernicus in the 16th century, at the beginning of the 16th century, and proposed the model that put the sun in the center. This basic, this ABC of our knowledge. Now, let me just put it straight. One model was very sensible, was consistent with observations, consistent with the Holy Scriptures, was consistent with the Aristotelian philosophy, and it was consistent with common sense. The other model was completely crazy. Was completely crazy. We need to realize for those people that model was completely crazy. And it had only one virtue that was only appreciated much later, which was that it came out to be right. But at that time, the model of Ptolemy was the model, the paradigm that was not really questioned by nearly anybody except for a few experts. So remember, we should remember this in the context. Okay, now to set the story, let me also drag you through some geography and history, because it's also worth realizing the setting. This is the map of Europe around the time of Copernicus. You see, Europe looked a bit different than it does now, although the geographical boundaries are the same. And I will not explain the countries that you know very well. You might be so surprised that Poland, Lithuania is here as one country, because it was the longest lasting union of two nations, a successful union of two nations in Europe ever, actually. And it was the biggest country in Europe at the time. There was also a Roman-German Empire. France is Spain, and Italy was divided into smaller states, including Papal State. And most of the happenings will be in this corner of Europe, in the north of Poland, in this corner. So you can say a corner of the sort of civilized world in some sense. But that's where Copernicus spent most of his life. Let me zoom it up and show you this map, and I have to explain it. The region that Copernicus must spend most of his time is called Warmia, in Latin Warmia, starting with V. And it was a very interesting region. It was a province of Poland that was part of a bigger province. You can see this, in beige, with this funny shape, that was reconquered. It was called Royal Prussia, was reconquered from the Teutonic Knights back in 1466, a few years before Copernicus, Nicolaus was born. And Warmia had a special status because it was a diocese, a Catholic diocese in the Catholic Church, and at the same time, a province, an administrative province. So the diocese was at the same time the ruling parliament. The head of the diocese, the bishop, was at the same time a prince of the diocese of this region. So this is the special region with the special arrangements. So being a bishop of Warmia was not just being a bishop in the Catholic Church, was also one of the princes, one of the rulers of the important provinces in Poland. And Warmia was surrounded by the Teutonic Knights order, Ducal Prussia, which was under the Teutonic Teutonic Knights order, but it was subordinated to the Polish king. I'm saying this because it was important in the life of Copernicus, it was important for the region, and it's worth remembering this. Now, I think you need to go back. So Copernicus spent a lot of time in Lisbon, which is the capital of Varmia and the site of the diocese with the cathedral. And then he moved to Fromberg, where he died. So he spent much of his life, adult life, productive life, really at the very end of the world, in some sense, away from academic circles and everything. But before we get there, he was born in Torun, in a town, nice town, on the border between Poland and previous Prussia, which was reconquered from the Teutonic Knights. So we have to remember that. Now, let's go through some early stages, some family and background, because it's going to be also quite important. He was born on the 15th of February, 1473, as has been mentioned. This is the building of his museum now. His father was also called Nicolaus Copernicus, Senior, and he was a merchant who moved there from Krakow, from the capital of Poland at that time. And that was unusual in itself, that a merchant from the capital will move to a small town, not small, but a provincial town somewhere in the north. There are conspiracy theories about this, but let's not go into that. His mother, Barbara Wassenrode, was a daughter of a wealthy Tory patrician and city councillor, a very rich family, local family. Getting married into a family like this was extremely unusual, different classes. How did it happen? Again, conspiracy theories, I'm not going to go into that, but that was in itself a very surprising thing. Then Nicolaus was with probably the third of four children. He had one brother and two daughters. And he looked like he would go into, good life. Wealth, no problems whatsoever for the rest of his life, probably following the career of his father. And then when he was 10, his father died. And if his family started running into financial difficulty, started selling property. Certainly that was not the time when you would think he would become ever a scientist and astronomer. Rather, he would probably try to survive or at least save the wealth of the family. Here comes into stage his uncle on the maternal side, Lucas Wassenrode, who offered to pay for his and also his brother's education. How nice. Well, Lucas Wassenrode, you need to know, he was a political animal. He had big plans, which to a large extent he realized. He became the Bishop of Varmia a few years later, and he wanted to have some assistants, some people that would be his supporters and assistants. He wouldn't be alone in that setting. So he chose those two young boys to be educated for him so that they serve him. And that's what happened, at least with Nicolaus. So Nicolaus and his brother were taken down to Krakow, to the capital of Poland at that time, from Torun down to Krakow of the Polish-Lithuanian Union. And not everybody knows that Krakow at that time was one of the top European intellectual centers, called New Athens. It was really one of the biggest centers in certain areas at least, for sure, in astronomy. And it was called the University of Krakow, who was one of the oldest universities in Europe. And Copernicus studied several subjects there. That was typical at that time, including astronomy, but received no degree in astronomy from Krakow. However, as I mentioned, astronomy was very strong there, very strong, top class, world class, with world-class scholars, not only from Poland, and especially Wojciech of Brudzewo, Adalbert Brudzewski, was very well known for his work in astronomy and astrology and in philosophy and many others. So Nicolaus must have heard about the geocentric system of Ptolemy that was being not only discussed but also questioned there. And the ideas of the heliocentric system were also discussed there, and he is pretty sure, though there is no record of it, that he got exposed to it. The impact of Krakow on his life was, as in his own words, very big. He said, "I was born in Torun, Krakow formed my thoughts." I think that says it best. What happened next? He had to go to Italy. Italy was the center of the world at the time for intellectual life. And he went first to Bologna, where he studied law, art, where he probably received master's degree, probably. Also medicine, probably studied, although there's little record of this. There's little record of his life, even from Krakow. He studied astronomy, probably. Then he had a brief visit to Rome in around the year 1500. There is record that he was actually talking about astronomy to scholars. Then he moved on to Padua for a few years, 2 years, where he studied medicine, where he probably received a bachelor's degree, law, Greek philology. Oops, what did I do now? And then in 1503, he moved to the University of Ferrara, where he received a doctorate in canon law from the Catholic Church. So Copernicus had no degree in astronomy. It's worth remembering this. He was an amateur. All right, good. So now let me put the Copernicus in the context of his time and epochs. He was a man of Renaissance, obviously. He lived during the time of Renaissance, which started, well, sort of around the 1500, but probably actually earlier. You know, Petrarch and others lived earlier, but sort of roughly 200 years or so. But Renaissance, which was a very important time, Leonardo da Vinci was nearly his contemporary, many others, a very busy time intellectually, and also in arts and so on. But Renaissance was preceded by Middle Ages, which lasted for 700 or 800 years, which to many is a time of dark ages. It was not so, really, because it was the time when first universities were established, one has to remember. Many philosophical ideas were worked out. And also, in our context, improving observations of the skies were done, of the sky was done. In Arabic countries, one has to mention, many Arabs, many Muslim astronomers contributed enormously to the development of astronomy. Also, Uzbekistan, best tables, star tables at the time of Copernicus, I think were coming from Samarkand. Yeah, Samarkand. And also China and Europe was also catching up, but was not really leading this effort yet. So this was an interesting story. And then let's go back, let's see what happened next. Returned to Poland after receiving a doctorate in canon law. He moved to Warmia to take the post of this canon of Fromberg in the Warmia canonry, in this local parliament. And he was basically an assistant, personal secretary, assistant, and physician, doctor of his uncle, Bishop Lucas Watzenrode. And he lived along with the bishop in Lidzbark. And it was a full-time job because, as I mentioned, Bishop Lucas was a political animal. He had many affairs, not kind of affairs you think about, you know, administrative affairs. He had legal cases. He had a lot of correspondence with the king, with princes, with the whole world. So Nicolaus was doing all this work, and it was a full-time job, and really a full-time job, more than that. Then, at some point, Bishop Lucas realized that Copernicus was spending some of his time somewhere else, especially late at night. And that led to some tensions. And in 1510, Nicolaus moved to Fromberg for the rest of his life, and he set up his observatory there. And soon after, 2 years later, because Bishop Lucas died. So you would think that Nicolaus had more time. Not really, because he was still very, very busy with very many things. He was at some point he was getting more senior, so getting more administrative duties. He became the second most important person in Warmia. So lots of administrative duties. And in his free time, he was making sky observations, working on his heliocentric theory. So you realize he spent most of his time doing something else. He did his model in his free time. How did he manage? In any case, certainly it was not the most optimal environment for doing research or making groundbreaking contributions to science. Living somewhere in the north corner of not even Europe, but Poland, away from academic centers, away from the academic life, and having to hide what he was doing from his uncle and others. Not the greatest, not the thing you want to do to be in order to do science. We should appreciate what kind of condition we can work on now today. And yet Copernicus is a man of Renaissance. We need to remember he was a polyglot. He spoke Latin, German, Polish, Greek, and Italian, I'm sure. Then he was busy, he worked in astronomy, mathematics, medicine, economy, and law, and he contributed important things to economy and law, and philosophy and theology. He was a diplomat, governor, administrator, accountant, translator. He was a very, very busy person. How did he manage to do this fundamental work among all those busy times? It beats me. And then here comes Commentariolus, a little commentary. It's the first manuscript, the first time when he actually formulated his model, or at least the basics of his theory. That was done when he was nearly 37 or something. So he was less than, he died at the age of 70. And he distributed handwritten copies to some of his friends and scholars in Poland and abroad. And I'm quoting it because it's really worth looking into this and seeing what it contained. It had an outline of the early version of this theory, and it has 7 postulates. Let's look through them. First, celestial bodies do not all revolve around a single point. So there is no single center of the universe, not the Earth. Then the center of the Earth is the center of the moon, of the sphere of the moon. That's correct, right? We know that. But then all the spheres rotate around the sun, which is near the center of the universe. And then in 4.4 in red, and I like this very much, the distance between the Earth and the sun is an insignificant fraction of the distance from the Earth to the sun to the other stars. In other words, the universe is much larger, much larger than everybody thought at the time. And that was, to me, a very revolutionary thought. Then he said no parallax is observed. Point 5, the stars are immovable. Their apparent daily motion is caused by the daily rotation of the Earth. Point 6, the Earth is moved in a sphere around the sun, causing an apparent annual migration of the sun. The Earth has more than one motion. He's put 3 motions of the Earth. 7, the Earth's orbital motion around the sun causes a seemingly reverse in the direction of the motions of the planets. Not fully developed yet, but all the ingredients were already there. Right? When he was nearly 35, 37. And what happened? He sent this around, and he received fairly little reaction to this. He was quite perhaps disappointed by this, because he was perhaps expecting some more. Well, he was recognized as a great astronomer, and he was invited in 1514 by Pope Leo X to take part in the early works on the reform of the calendar. You know, the calendar, Julian calendar, was eventually changed by the Gregorian calendar. But and that apparently he contributed enormously to this, but that was not that great. Then, many years later, in 1533, the Copernican system was presented to Pope Clement VII, who apparently liked it, the record says, and some cardinals. Now, 2 years later, the person who presented the model of Copernicus, 20 years after the Commentariolus was issued, the person who presented the work became an assistant of Cardinal Schönberg, who was the Pope's advisor at the time. And Cardinal Schönberg wrote a letter to Copernicus urging him to publish his results. He offered to cover the cost of publishing, even. So there was a growing interest in this theory. And also several top intellectuals, clergy and laity, showed increasing interest in the Copernican model. Erasmus of Notre Dame, for example, there's record that he was interested in this model, was writing to the local bishop asking to convince Copernicus to publish. And yet, Nicolaus Copernicus remained reluctant to publish his opus magna, his great work, which he completed by 1535 and was basically ready to go. And here comes into play Rheticus. Who was Rheticus? A very important element in this whole story, because Copernicus was basically 10 years before his death, getting old, and at that time, people didn't live that long. And without his work being published, he would have been basically forgotten. And here comes Rheticus, a young mathematician from the University of Wittenberg in Germany. He became interested, or got interested by others, in the works of Copernicus. And in May of 1539, he arrived in Fromberg. He went to Fromberg, and he started working with Copernicus and spent 2 years there, looking at the sky, going through the books, to the works, and so on. And Copernicus allowed him, apparently, to publish the so-called Narratio Prima, a report, in 1540, where he summarized Copernicus' idea, cosmology, in a very nice way, apparently still a very nice introduction to the model, in which he said that the Earth is a planet rotating on its axis and revolving annually about the central sun. That was, the first edition was actually done in a nearby Gdańsk, city of Gdańsk, and then the second edition a year later, and a positive reaction to this, generally positive reaction to the report, convinced Nicolaus Copernicus to finally agree to publish his book. But you can imagine that it was because somebody decided to go from Wittenberg to Warmia to convince, to learn about this model. It's only because of that the book was published and the result became known. Otherwise, it would become forgotten, simply forgotten. And on top of it, there is another twist to this story. I mean, Rheticus returned in October of 1541, 2 years before, a year and a half before Copernicus' death, back to Wittenberg with a charge to publish the book of Copernicus in Nuremberg. Now, I'm mentioning Nuremberg and Wittenberg. Let's look at the chronology. What happened at that time? Well, a few years earlier, Lutheran Reformation started in Germany and started spreading throughout Northern Europe quite rapidly. And in particular, here's the map of that time, which is the map of predominant religious religions. And you can see that the Lutheran part is mostly, west, east or central part of Germany, the southern, is where Wittenberg is and where Nuremberg is. There was the Lutheran part, while Poland, marked here as mixed, was actually mostly Catholic, still is, right? Although there was some Lutheran influence. Also, the Duchy, the Teutonic order resolved, and they became, sorry, what did I do? Became Lutheran. You don't know perhaps this, but to go as a Lutheran going to a Catholic country, you were risking to be put into jail. Going as a Catholic to a Lutheran country, you were risking the same or even losing your life. So Rheticus, a Lutheran, went to a Catholic country to learn from a Catholic canon about his discovery and was instrumental in having his book published. A Lutheran. Why is this so funny? Because Luther condemned the work of Copernicus outright. Back in 39, basically at the time when Rheticus went to Copernicus, Luther ridiculed Copernicus and his work. He said it's crazy. So he was a Lutheran who saved the work of, who was instrumental in having the book published in Nuremberg, which was also Lutheran. What did the book contain? The preface by Johannes Petreius, the publisher, an unsigned note to the reader concerning the hypothesis of these works. I'll come back to this. A letter of Nicolaus Schönberg, Cardinal of Capua that I mentioned, to Nicolaus Copernicus, urging him to publish, and then a letter of Copernicus to Pope Paul III, which was a preface to his book, where he explains why he decided to do it, why he decided to publish it, and also why he was afraid of publishing it, worth reading. And then it was followed by 6 technical books. Now, Copernicus received a copy of this book, published in March, just before his death on the 24th of March. Some people say that was actually just on the day when he died. He looked at the copy and he died. Half a year later, in December, he suffered a stroke, and he spent the rest of his life in bed, half paralyzed. So what an ending of his life. You know, the book appears at the last hours, maybe, of his life, and that is published. But there was this note. This unsigned note was added without the consent of Copernicus nor Rheticus, and it was written by Andreas Osiander, who was a Lutheran theologian and Protestant reformer. And the note stated that the model should be treated as a mere hypothesis and useful mathematic tool, and not as something real. Let me just quote from this note. Reports about this novel hypothesis of this work, and so on. This hypothesis need not be true, not to be true nor even probable. On the contrary, so far as hypotheses are concerned, let no one expect anything certain from astronomy. Just what I like. And then the main text was also modified, the 6 books, changing most definite statements to sound like hypotheses. So you would say by today's standards, it was a fraud, adding a note, which everybody thought was due to Copernicus, and making those changes. Copyrights at the time had a different meaning, no meaning whatsoever. But still, some people say that Osiander tried to sort of make it easier to get the book published in the Lutheran part of Europe. I don't know. Anyway, the changes were strongly criticized by Rheticus and also Copernicus, but it's not clear whether he actually did it. Anyway, let's move on. Why was Copernicus reluctant to publish his book in the first place? It's worth reading the letter to the Pope, because he explains it. He was fully aware that the model would be considered crazy. I just quote here, people who know that the consensus of many centuries would regard it as an insane pronouncement, that if I made the opposite assertion, that the Earth moves. So he was aware that he was going against the whole world. He was afraid of being ridiculed by non-experts, and here's an example of Luther, but also others. He said, there will be bubblers who claim to be judges of astronomy, although completely ignorant about the subject, and badly distorting some passages of scripture to their purpose, would dare to find fault with my undertaking and censoring it. And then, when I weighted these considerations, almost induced me to abandon completely the work which I had to undertake. He was afraid of being ridiculed. He preferred instead to present his work only to friends and scholars. And he writes it, I debated with myself for a long time whether to publish it. And then I said, rather, I decided to follow the example of the Pythagoreans and certain others and who used to transmit philosophy's secret only to kinsmen and friends, but not in writing by the word of mouth. Imagine, he had this opus magna, this great thing, and he didn't want to publish it because he was afraid of being ridiculed, and he thought that spreading the word around would be sufficient. Not by today's standards, obviously. Crazy, right? And fortunately, it did happen. Let me show you how it looks. You can go to the internet and see many copies of the book, many pictures of the book. You have never seen this one. Why? Because it's my own copy. My own copy in Latin, in Latin, so I not read this one. And then let me flash to you the 6 books, the content of the 6 books. It's in small print, very, very full. It starts with the universe is a spherical sphere. The Earth is also a spherical. It's also spherical. and so on, and so on, and so on, and so on. The 6 books are full of content of technical considerations, tables, theorems, figures, and so on, explanations. They are very technical. So he did it, and 400 years later, on the 400th anniversary of his work, a well-known Polish painter, Jan Matejko, painted this well-known painting. I don't know if you can see it with the light, but it shows Copernicus in his tower in Fromberg. He realized how the universe works. As it says, conversation with God. God, how beautiful it all is. He must have been astonished. It also shows the primitive instruments that he used to locate the stars in the sky. Here's an earlier version of this painting. If you have a good eye, you will notice some differences. Can you see the differences? There's a telescope. Matejko put a telescope at his feet, and then others told him, look, the telescope was only invented by Galileo 100 years later. And so he removed it from this official painting. Anyway, I think in this picture you can see the astonishment of Nicolaus Copernicus, and which you can quote here what he wrote in the book. And what's more beautiful than the sky, which envelops everything that is so beautiful. I think he must have been beautiful, really astonished once he realized how the sky works. Here is another photo. This is a photo of this original painting that was displayed at the exhibition in the Royal Castle in Warsaw in June, with some figures which you should be able to recognize. You should be able to recognize all 4 of them, although one of them is present here. This is Art MacDonald, Nobel Prize winner in 2015, neutrino oscillations. Barry Barish, gravitational wave discovery, 2017 Nobel Prize. And then Jim Peebles, 2019, physical cosmology. Great guys who also came to the Copernican Congress earlier in June and in February, then also in June. You could also see some other things like the astrolabe that was used at that time and also earlier to locate the stars in the sky. There's a nice monument of Copernicus, which I like here. Why did I like it? Well, you can sort of see this, his left foot on 2 books. If you do a zoom, maybe you'll not be able to see it. Books are by Ptolemy and Hipparchus. I think it was the author of this monument overdid a bit. Anyway, the revolution happened. The revolution happened. It was published. That is his model, sun in the center and the orbits. And then what? The book was read by many scientists, Brożek, Brahe, Kepler, Galileo, Pascal, Erasmus of Rotterdam. Also the Polish king read it, for example. Johann Wolfgang Goethe said, among all the discoveries and opinions announced, nothing made such a great impression on the human mind as Copernicus science. But it came very slow. Let's go through this model in the context of what was observed and as observed. How does the solar system look like from the Earth? We know the sun, the moon, the planets move around the Earth in the sky. So the sun, the moon moves from east to west. The planets like Mars, Jupiter, and Saturn, from time to time appear to temporarily move backwards, right? The retrograde motion before resuming their normal east to west motion. So it goes like this, go back for some time, and then it starts going back in the right direction. So that's the way it goes. This retrograde motion was a big puzzle. And in the Ptolemaic system, let me go through the Ptolemaic system and its problems that started appearing. The model, as I said at the beginning, it successfully described what was observed. The motion of the sun, the moon, and the planets around the sun, around the Earth, were described properly by the Ptolemaic system, also mathematically. The planet's retrograde motion was also described through epicycles. Planets would go through small circles around their orbits. So this was also be done. So this epicycles was one of the key features of the Ptolemaic model. But with improving observations, you had to add more and more and more and more epicycles, and it became just very complicated. And it became clear by some 10th to 12th century that the Ptolemaic model, while initially elegant and common sense, had more and more problems. Now, what was the Copernicus starting point? I don't know, but I was trying to imagine myself. How did he do it? So let's assume the heliocentric system. The moon and the planets, including the Earth, move around the sun. We know that. That's the heliocentric system. But the key question is, how does the motion of the sun and the moon and the planets look like from an observer on the Earth? Because we are on the Earth, you observe it. And the answer is the same as in the Ptolemaic system. So basically, we see the sun, the moon, the planets move in the sky. So Copernicus developed a detailed mathematical description of the motion of the sun, the moon, and the planets as seen by an observer on Earth. And that was a technical, difficult part to do, including the retrograde motion. Because in his model, the retrograde motion was explained by the fact that the Earth moves at a different speed than, let's say, an outer planet, and at some point, the Earth sort of takes over, and the outer planet in the sky appears to be moving backwards before resuming its normal condition. So that was done automatically. That's nice. For the inner planets, likewise, Mercury's retrograde motion could also be explained in a similar way. So he described the celestial motion in terms of pure combination of circles. Owen Gingrich, in his nice book, says it very clearly. But then, what were the, just to summarize, the greatest contributions of Copernicus? He created a full-scale, detailed geometrical model of a heliocentric system, where the Earth and the other planets were moved around the stationary sun. The apparent retrograde motion of the planets is caused by the Earth's motion. The Earth has three motions. He put it, I think, for the first time together: annual revolution of the sun, the daily rotation, and the annual tilting of its axis. But then his model had mathematical structure, had parameters, and predictions. In this respect, in the words of Jim Peebles, the model of Copernicus had all the features of a first modern theory. It was mathematically sound, it had parameters and predictions. And he said this was the first model of modern science. So in the title I referred to his statement. It was the first model which had all the right features, and then on top of it became right. But then on top of it, to me, among the greatest contributions of Copernicus was the fact that he claimed that the universe is much larger than what was thought at that time. Okay, let's move on. The model of Copernicus was a great achievement, but was not fully correct, as we know. The biggest problem was that Copernicus, like Ptolemy and everybody else, assumed circular orbits and constant speeds. Mainly because of the model did not fully agree with astronomical observations. To correct for this, Nicolaus Copernicus also had to introduce epicycles. That was the problem. Although, you know, he was still under the influence of Aristotle, that had to be circular and spherical. Then the model was met with much interest, but also skepticism. For one thing, the biggest problem to me of the model of Copernicus was that he had no smoking gun prediction that could immediately convince the world that his model was correct. So how long did it take? Let's have a look. Tycho Brahe was, I will mention a few contributors to the whole story. Was first who actually looked into this on the observational side. I will forget about the philosophical, theological discussions on this side because it's another story. Johannes Kepler, as we know, contributed enormously. And after the Lutheran Reformation, also the Catholic Counter-Reformation started. And Galileo Galilei appears on the scene. And then after that, Isaac Newton and James Bradley. So let me go through their contributions and how they developed, how they contribute to the Copernican theory and its acceptance. Briefly, Tycho Brahe lived, he was born basically a few years after Copernicus died. He was a wealthy and brilliant astronomer from Denmark. He built up his own observatory, and he had a great idea. He said, if the model is correct, then we should see a parallax of a bright star. By bright, he meant a star which is probably not at the sphere of fixed stars, but closer. You should see a parallax. I assume most people here are physicists. I don't need to explain what parallax is. If you don't know what parallax is, you just take a finger in front of you and close your eyes, left eye, right eye. You will see your finger jumping left and right relative to the background. The same would happen with the nearby star against the fixed stars. Its position, depending on the position of the Earth, so in spring and autumn, would be jumping a bit. Well, Brahe had a brilliant idea, and he failed to see the effect. And he decided that the model must be wrong. He rejected the model. He didn't know that the effect was 100 times too small to be seen at that time. So he invented his own model, actually not really his own model, but he adopted another model in which the Earth was at the center, but the sun and the moon were orbiting it, but other planets were orbiting the sun, a hybrid model, which is a bit crazy, honestly, although also discussed at that time. And even Johannes Kepler criticized it. Who was Johannes Kepler? He was an assistant of Brahe, student or assistant. So here comes Johannes Kepler, another Lutheran, by the way. And Johannes Kepler made fantastic, important contributions. He said he replaced orbits, circles as orbits with ellipses, with ellipse. Ellipse, we know what this. You have two focal points rather than one as a circle, and he then realized that the speed cannot be constant but varying, and he got rid of epicycles altogether. So that was his great contribution. And I read somewhere that he was studying the book of Copernicus, and in one of there's a copy of it in Leipzig, and one of the pages there is a handwritten note of Johannes Kepler, ellipse. Although before he did it, probably he tried several models of various shapes of how to form the sky. Anyway, so he did his great contribution. In particular, his first law says planets move in elliptical orbits around the sun. That was really big because, as I said, everybody thought that things had to be perfect shape, circular and spherical. I remember when I was a young boy and I realized that planets move around elliptical orbits and not circular orbits. I was disappointed. So anyway, so that was his great contribution. Then comes Galileo. Galileo was the first one to use a telescope to observe the sky, and he saw the phases of Venus, like we see the phases of the moon, new moon, first, second, and the full moon, and so on. He saw the same with Venus, with a telescope. And in the Copernican system, it was very natural. Right? The Earth, the phases of Venus are basically depend on the relative position of the Earth, Venus, and the Sun. Depending on how the Sun illuminates the planet of Venus, you see different phases of Venus. But one has to remember, this was very convincing to many people, but phases of Venus could be also explained in the Ptolemaic system. epicycles. So there was not a definite proof. Anyway, we know that Galileo ran into problems with the Catholic Church, with the Inquisition, and so on, the Roman Inquisition. But suddenly that provided a very strong argument for the Copernican model. By the way, I didn't say that, but already in the 16th century, before Galileo, the book of Copernicus, the model of Copernicus, was accepted and taught in European universities, including Salamanca, for example, in some universities as a must, so as an obligatory model to learn. So it was getting accepted, but there was no definite proof. And there comes Isaac Newton. Isaac Newton, I don't need to introduce to you, a great genius. And Newton formulated his law of gravity, universal law of gravity, from which the motions of the planets along elliptical orbits just followed. Beautiful. But even that was not a proof. It was obviously by then very much accepted, the Copernican model, but there was still not final proof. And finally, I want to mention James Bradley. James Bradley, who lived even further, even later than Isaac Newton, discovered the aberration of light, of stars. A brilliant idea. Namely, basically, if you run, you sense an apparent wind, and if you're a sailor, if you sail, you know that the apparent wind is actually closer to the direction of motion than the real wind. The same is with light, a very nice phenomenon. As a result, stars move about their true positions in the sky along little ellipses, and that's what he observed. And to me, that was the real sort of stamp on the end, which would have convinced me. All right, so I think this is how the story developed, and let me just try to summarize. First of all, let's look at Copernicus. The most unusual case of Copernicus, I told you, he spent all this time away from academic environment. Even his family was not really the family that would normally grow scientists. He never had a degree in astronomy. He had to spend most of his time on something else, on things which I don't think he liked particularly, but he did it actually with a lot of, very properly. He never had a research grant. He only had one student, and he had only one publication in astronomy. And yet, that was enough to become, an icon in not only in astronomy but in science. The Copernican revolution. Can we talk about Copernicus, a Copernican revolution of him, or rather a progression? There were ideas against the paradigm of deployment Ptolemaic system, a very sensible model. The ideas were starting from antiquity, from the time of Aristarchus of Samos, but they were just ideas. There came concrete detailed model of Copernicus, and that was what he did. He did it. And then there were attempts at verifying it. Tycho Brahe, 30 years later or so, or even more, failed to actually verify the model and rejected it. Kepler, some 60 years after the work of the life of Copernicus, corrected it. There were strong arguments in its support. Galileo, 67 years. Bradley, nearly 200 years. And understanding it why, from how to why, again, over 170 years. So it gives you the scale of over which the model got evolved a bit and got accepted. That shows you, I think, how science also worked at the time in many respects, especially a revolutionary idea as his. So my time is up, I presume. So let's just try to summarize. Science often advances through many unexpected twists, accidental events, false assumptions or motivations, sometimes errors, but it does advance. And the story of Copernicus and his heliocentric theory is a prominent and a dramatic illustration of this general experience, I would think. And that's why I decided to share my excitement about how this story developed from the first steps until today. Thank you very much.
Thank you very much, Leszek. That was very entertaining. So there's plenty of time for a few questions.
Thank you for the very nice presentation. I think it puts the history of astronomy into very nice perspective. So I have a very quick question. So as is very well known, the heliocentric system was invented by Aristarchus in the 3rd century BC. And in the first version of the Evolutionibus, Copernicus mentioned this, but in the second version, this comment disappeared. Do you know what happened there?
In the first version of the I don't think it was mentioned.
It is. This
Not
is
in
even
the
written in
book.
Wikipedia. I just checked.
In the Nuremberg version?
In the first version, yeah. And in the second version, this comment was gone. Do you know what happened there?
If we don't read this, so first of all, he does not mention it in the letter to the Pope. In the Nuremberg, in the first edition, it's not mentioned there,
Okay.
and people were surprised. Probably he just didn't know about it.
No, I think he knew because Copernicus had studied the ancient Greek astronomers. He knew ancient Greek, as you said.
Well, experts are divided on this.
Okay.
They were puzzled but divided. He probably didn't know, or maybe he did, but it was the work of Aristarchus was not didn't survive, right? It was no original work. It was mentioned, I think, by Pythagoras later in his works, and it's not clear why. But honestly, I don't think he tried to diminish, the role of Aristarchus, because when I read whatever I read from the letter to the Pope, I read this whole, and whatever I learned about Copernicus, he was a very honest person, a very, whatever he did very honestly, very, he was very, very just in whatever he did. He was not an act of sort of being dishonest. He probably just missed it.
Thank you very much.
Yeah, but it was only Aristarchus had this great idea, but again, the idea was also put forward by others, or repeated by others, developed by others. But there's a difference between having ideas and working out a detailed mathematical model. That was the thing that Copernicus did. And actually, when you read the introduction, the letter, it's really worth reading. It's a pleasure to read it. He explains.
In terms of modeling, the geocentric model of Ptolemy, even it's wrong. I mean, it was a very detailed model. People could make predictions.
You're absolutely right.
It was a mathematical model.
You're absolutely right. You are absolutely right. Ptolemy did a fantastic piece of work, and in some sense, you can say that he was. You could attribute modern science, the beginning of modern science, even to Ptolemy, because he did a very detailed mathematical model. Yes, indeed, except that his model came out to be, wrong. But yeah, absolutely right. So I think it would be hard to tell that modern science started from Ptolemy, but it definitely started with Copernicus. But I agree, and I said it at the beginning. The work of Ptolemy was magnificent. Magnificent. He described successfully what was seen and what was, described by the Holy Scriptures, and also, at least, from the point of the author, the authors who wrote it, and also from the point of the Aristotelian philosophy. The Earth was at the center of the universe, so it was a paradigm. We discussed with Juan before. What kind of discovery today would one make or claim would one need to make it a comparable, sort of outrageous claim to the one of Copernicus? It was outrageous, completely outrageous, crazy, and Copernicus was afraid.
Thanks again for the beautiful presentation.
Thanks.
More questions?
No.
Thanks a lot for the great talk. So you mentioned like the seven. Sorry, can you hear me now? Okay, so you mentioned like 7 kind of points from what basically, well, his theory or the way he was thinking, and one was like the sun is at the center and everything is around the sun, But then you also mentioned, like he mentioned himself, that the stars or whatever, they are very far from the sun. So compared to the distance of the Earth to the sun, they're so you were basically saying that Copernicus somehow found out that the universe is very big. But I'm just wondering if you've seen, like, well, do you think he was ever puzzled by this fact that, you know, if they're very far from the sun, how come the sun is the center and this whole thing is actually just rotating around the sun? Well, he had never been puzzled by this, that's thinking that maybe actually the sun is also kind of moving or something. He never thought about this.
Yeah, it's a very good point, actually, because, you know, the models of the universe at that time were, by our standards, extremely primitive. They were mechanical models, right? They thought that those spheres would be, you know, some sort of invisible, therefore crystal spheres, but they were mechanical spheres that were moving in the sky. There's enormous mechanical spheres moving in the sky. So everybody thought so, because nobody knew, you know, interactions that would be propagated without, you know, material bodies. So, like everybody else, he thought that there were enormous spheres, and there was a sphere of fixed stars. There was a sphere for the sun, for the Earth. There was a sphere for the Moon. There was a sphere for the other planets, and this was all mechanical. So I think he realized that since there is no parallax seen for the fixed stars, they must be very far away. I think he estimated how far they would have to be by the accuracy at the time. And he realized, I don't remember the exact numbers, that simply those fixed stars had to be much further away than what was thought at that time. Now, it's easy for us to make such statements now, right? But at that time, already making this crazy claim, and then saying that not only the sun is at the center, but also the whole universe is much, much larger than people thought at the time, that would make it double crazy. So I actually appreciated this claim, because I think he was not just a technician who did some work. He had some grand thinking about how the universe works. And he realized it had to be enormous. It had to be very much larger. But on the side of how it worked, it was still those spheres. And even at the time of Kepler, Kepler tried to figure out various figures that would make the system of spheres move in the sky. Very primitive on this side.
So I mean,
we needed Newton for that.
That's actually a good point about the spheres that you were talking about, the crystal or whatever. So wasn't he or maybe other people puzzled by the fact? I mean, there wasn't. If you go on Earth, you don't see any crystal sphere attached to the Earth, right? So what were they thinking? I mean,
I'm sure he
should have been somewhere, right? He should have been able to go there and find it, right? So
I'm sure he was puzzled, but like we are puzzled why the cosmological constant is what it is, right? But we have no good answer to it, you know. Right. People just puzzled, but they didn't know. But you know, okay. But you know, 200 years later, Bradley did his fantastic experiment. But then people came up with the idea of ether, because they didn't know how to explain. You know, the light would propagate through vacuum. You know, this crazy ideas are with us, and then only some time later we realized that they were crazy.
Thank you very much.
For crazy views.
Any further question?
No, just a comment. No, that also he has Copernicus. He has something in common with Newton and also with Darwin, no? Because the three of them were reluctant to publish their works. They were not sure about, in a sense, about the results, or they didn't want to publish it for others to know, and so on. No? It's curious, no? The three of them had the same issue. No?
So thanks. I don't know about whether Newton or Darwin were unsure about the results, but Copernicus was sure about his results. He was not sure if he should share them with the general public. He thought that the right thing to do would be just to share it with his friends and scholars, and not to get exposed to the general ridicule. and for good reason. You know, he got some beating really in the media at that time, right? But honestly, probably less than he feared. You know, he got criticized on philosophical grounds, theological grounds, but not until the time of Galileo, the criticism was actually, I would say, justified. You know, in the paradigm of that time, of those people who accepted Aristotelian philosophy and the Bible, the Ptolemaic system was just common sense. That was precisely what fitted everything. It had problems with observations, but was this enough to reject it and make such a fundamental change? No, the model was criticized by one theologian, philosopher, on the basis that it doesn't explain anything. It just puts a different, you know, model, but it doesn't start from anything fundamental. So this kind of considerations, this kind of criticism, I can accept. I could imagine, maybe I would invite you as well if you want to do this. Imagine yourselves living in those times, being scholars in those times. How would I react to a model that I would hear about from somebody living in the outskirts of Europe? I would probably be very skeptical. I don't know about you, but I would certainly be very skeptical. Imagine the minds of those people. So I don't know about Newton and Darwin, certainly great contributors as well.
I would say it's more similar to Darwin, no? Because Darwin was also afraid of publishing his work because it was against religion and so on.
May I comment here? Probably you mentioned Reticus. In the case of Darwin, it was Wallace. So in both cases, he had somebody else to put forward. In the case of Newton probably was Hooke, put forward a theory which might overshadow their initial ideas. Say, wait a minute, this guy's not going to get before me. I already thought of this. So I put this forward. So in the three cases, there was somebody just at the edge going to say exactly the same thing and still, wait, I had this idea before, so why not publish it? So only those three cases have this thing in common.
So the lesson to the more senior boys, people in the audience, and also younger ones, if you have a brilliant idea, publish it. Not because it's...
If they publish it. More questions? Actually, I have a question, which I already posed to you, which is, of course, this thing doesn't come out of the blue. It happened in a particular historical context. The America had just been discovered. How much did the discovery of America shaped the ideas of Copernicus? Did it have any influence whatsoever? Does he mention at all that the fact that not just the America itself, but the fact that it could be circumnavigated by what Juan Sebastian Cabral at the end finished the whole voyage, but it's also Magellan. Did that play any role in his understanding? This is 1519, so it's before he published. So how did it matter?
We don't know. The thing is, we don't know. There's so little known for sure about Copernicus. That's why there's a whole field of research called Copernicology, where people put forward various speculations and try to convince the rest of the world that they are correct, including, as I said, you know, the fact that his father moved from Krakow to Toruń on a special mission. Some people say from the king, who one of his advisors. We don't know, simply don't know. There's little record. There's no record whatsoever of what Copernicus studied in Krakow. There is little record of Copernicus. The only record from Krakow was that at some point he and his brother ran out of money and they requested more money. And I'm sorry, their fees were paid in full. That's the only record of their studies in Krakow. But because of the academic environment at the time in Krakow, we can deduce that that Nicolaus was introduced to the problems in astronomy and the ideas of the heliocentric theory. So I was asking myself whether, and I would actually wanted to ask you, living in Spain, to what extent the fact the voyage of Columbus convinced the world that the Earth was round. I think it was sort of getting accepted, right? We agreed. But remember the voyage of Magellan, or his expedition, he didn't return, was only completed in 1525, 10 years after the Commentariolus, right? So I think it was basically getting accepted, at least in the academic circle, that is a sphere, right?
Thank you. Thank you very much. If there are no more questions, let's thank Leszek again. And there is coffee now for everyone. Yep, outside. And we reconvene for the conference tomorrow at 9:30.